Nestled in the heart of Kentucky's horse and bourbon country, almost central between Lexington and Louisville, is the capital city of Frankfort, and operating here since 1958 is Harrod Concrete and Stone Company. Each morning before the sun rises over the bluegrass, Harrod's employees begin the arduous task of producing crushed stone and concrete for various projects large and small in central Kentucky. In order to do this effectively, Harrod requires some large, heavy, and expensive equipment. Technological advances in this type of equipment are typically slowly adopted by industry, either because of the high costs or historical standards. Harrod believes that a new drilling technology will keep them at the forefront of the mining industry in Kentucky and help them continue to mine limestone safely, efficiently, and sustainably. In order to see where the process of extracting limestone begins, we need to go underground. Harrod's underground limestone mine consists of a series of corridors laid out in a grid pattern. These corridors are created by drilling into the limestone, inserting explosives into the drilled holes, detonating the explosives, and then removing the rubble to be crushed, sized and sorted, then eventually sold. Back underground, mine foreman Aaron Edwards is using surveying equipment to lay out a mine corridor advancement and the center line for Harrod's new drill rig.
My name is Aaron Edwards. I'm with Harrod Concrete and Stone. I'm the mine foreman, and what we're going to be doing today is we're going to be transferring some centerline pins for the advancement of our mine. I'll turn the laser on now and we'll begin this process. As you can see, my laser reflecting on a centerline pin that has already been in place by our engineers that do our surveying every year, and I'm going to center on it right now. So I've zero set my transit onto that pin right there and the pin that is directly above me, and now I'm going to turn my total station 180 degrees. And what we will do now, when we get zeroed on 180 degrees, we will shoot 98 feet. I'm measuring now to a prism, which is the same as any surveyor uses or engineer uses to survey. 98.000. That's precise. That's what we're going to shoot it at. Now we're going to check to make sure that our right to left, side to side is correct. Now, I know you can't see it inside the transit yourself, but that is 100% perfect right there. So now what we'll do, if you can give us just a minute, we're going to move the total station from this point to that new point that I just set down there. We're going to shoot the center of the shot for our new Sandvik drill and show the measurement process from the roof down to the 23-foot mark, and then it will be 6 foot laid off on the wall for the operator to know to program his Sandvik drill. All right, he's gonna mark our center, and he's gonna follow my mark coming all the way down the wall. 23 feet from the ceiling down to the back end of his laser, and he will put a T at the top of his center line mark. Then he will put 6 foot, because our total heading height is 29 foot from the ceiling to the floor. And that's how we lay off all of our centers for our new Sandvik drill.
The Sandvik DT912D is not just another drill rig, it is a technologically advanced, computer-controlled piece of equipment that has been designed to revolutionize the process of limestone extraction. This Swedish-made, diesel-powered drill rig is 4-wheel drive and has an articulating chassis. The drill is equipped with enough lights to ensure that the operator has a clear view of his surroundings, increasing safety. The universal boom allows for minimal repositioning of the drill rig. It is able to extend and articulate into position for optimum efficiency. The noise and vibration insulated cabin provides the operator with a safe, ergonomic workplace with excellent visibility. The controls are intuitive and conveniently placed around the large display. Sandvik's iSure modeling software allows Harrod to create a precise drilling sequence that helps to reduce overbreak and prevents unnecessary fracturing of the surrounding rock. The onboard computer controls the precise depth and angle of each borehole so that all of the holes drilled end at the same depth. This precise control ensures that the fragmentation of limestone is optimized, resulting in smoother rock faces that require less scaling. This not only reduces waste, it enhances safety. Now, to help explain the blasting process, we'll go to Bert van Houten, over at one of the faces that is prepped for blasting.
Hello, I'm Bert Van Houten with Harrod Concrete and Stone. Today we're going to explain the blasting in our underground mine. Our blasts are felt and heard as one explosion, but they're actually a combination of 12 different explosions going off within milliseconds of one another. This is a typical shot designed by our engineers at Austin Powder. There are 46 holes in this shot pattern, 7 holes along the top, 7 holes along the bottom, and 4 rows of 8 holes going through the middle. Each one of these holes is drilled at a different angle and a different depth. They are then loaded with explosives and time delays. For instance, this hole is drilled and the delay in here is 0 milliseconds. This will be the very first hole that goes off in a series of explosions. The middle goes off first, then right side, left side, left side, and then top and the bottom. If I look at this bottom hole, it's a 350 millisecond hole. That is the difference in time between these two shots. Even though they're lit at the same exact time, the explosion will happen milliseconds apart from one another. This helps the vibration and the sound waves from traveling, because this is not one big explosion. These are actually 12 different explosions going off. Each hole holds 17 to 20 pounds of explosives. So at each time, there's only 100 to 120 pounds of explosives going off milliseconds apart from one another.
Harrod Concrete and Stone purchased this drill because of their commitment to safely extract limestone at their location. They believe that the precision that this equipment offers will allow them to continue mining safely under their Frankfurt property for years to come. Harrod strives to be a good neighbor and active in the Frankfurt community. This is why they maintain lower than allowable surface vibration levels. The surface vibrations produced by their blasting are monitored by seismographs placed in various locations around their quarry. Harrod Concrete and Stone plays a critical role in the economy and community of Frankfort, Kentucky. They and their employees are an integral part of Central Kentucky's construction industry, and with investments in advanced mining technology, they will be for years to come.